All right. Welcome, welcome, welcome. Happy to have you guys. Hope you're doing well. We have a heck of a lot to do today. We probably will not get through it. I hope that we can get through at least most of the notes, but I'm not sure if that will be the case or not. So I'd like to start out with saying what we're doing today is our introduction to F#. I'm going to probably start at point 0 being here are the tools we need to download and get set up and use. I've got suggestions for you. There are many ways to do this, so I'm not going to tell you that what I say is the only way that you can do it, but this is the way I will definitely help you with because I have experience with it. So part 0, we're going to need a copy of .NET. We're using .NET Core for, I believe, every assignment this semester. I fixed the one assignment that wasn't .NET Core. And Java for a couple of things. Just had to think about that for a second. So we're going to use .NET Core. There is a relatively recent version 5.0 out that I will make sure that my projects compile for. We use Git, so you need to have a copy of Git installed. And you're going to want some kind of an IDE or text editor. Now, I suggest that you use JetBrains Writer, mostly because it's a product that I can support on all platforms, so the Mac users can be on the same page as the Windows users. Windows users, if you, for some strange reason, like Visual Studio, more power to you. It does work with .NET Core. I don't have much experience with that, though, so I'm not sure how much I can help you. I don't have a Windows machine that's just like here, right? I do have one down right over here, but it's a piece of junk, and I haven't turned it on for like 5 years. So, that said, JetBrains Writer is really a pretty good replacement. There is also an option that you could use Visual Studio Code. There's a nice plugin for Visual Studio Code that can get the job done as well. If you want help with that, I'm happy to do that, probably over on the Discord. For today, I'm just going to demo one way. So, let me take us over to the web browser. And the first thing I want to show you is Writer. JetBrains Writer. This product is one of the IDEs from JetBrains, who makes IntelliJ, which is by far the best Java IDE out there. Writer is a cross-platform .NET IDE. I will put some notes. I will put some links somewhere, but you can find these things with your Googling skills. I hope you have the Googling skills to find it, really. So Writer here, it notes here that you get a free 30-day trial, but you are a student. You get all of the JetBrains products for actually free. Writer looks very much like any other IDE, and it has very nice debugging features and support for all of the things that we might want. I would suggest that you use the Google and you search for JetBrains Student. And the first link that you come across, whether you use DuckDuckGo or Google, to be honest, can't guarantee other search engines, will be the way that you get this all for free. You sign up with your university email address, answer some questions. You will get their full suite of products for free, which is pretty great. Just so you know, if I haven't shown you this before for some reason, if we go to the store and we find the product that you get for free, that is a $500, oh wait, sorry, it's $650 product for the first year. Second year, $519. Third year, $389. Please take advantage of the fact that you're a student. While you're a student, you will dearly miss that capability if you find out too late. Yes, that is correct. You do have to renew it once a year. I haven't heard from any alumni if they keep renewing it or not. I suspect that since you don't lose access to your email and JetBrains doesn't really check, you can probably keep this for a long time. All right. So JetBrains Writer, product 0, very good idea. Go grab it. Don't delay, just grab it. The other thing you will need is a copy of Git. Now, Git lives at git-scm.com, and you can search for that. If you are on a Mac or Linux machine, you already have Git and you don't have to do anything. If you're on a Windows machine, you're going to have to grab it. It will install on Windows a thing called Git Bash in your start menu, and that's where you can interact with Git. I'm not going to demo Git today. I will post a video separately about Git. It's just we don't have enough time today for that. But you are going to need a copy of Git to interact with the project on GitHub. Technically, Writer also comes with a Git client. The only trouble with that is that they kind of overload the functionality of Git. Oh no, my iPad cannot update right now. They kind of overload the functionality and it can cause some issues with the way that you use it. So if you know Git inside and out, it's a fine tool to use. If you don't, I don't recommend it. I recommend interacting with the Git command line. It's the canonical way to use Git. Again, I will post a different video about Git, just noting here that you need it. All right. So with that said, I have posted the first homework assignment. We are probably not going to get through quite enough today that you might actually be able to really do anything with it, but you can at least grab it and get stuff set up. So that's linked here, beginning F#. I'd like to note the way that this works the first time that you interact with my GitHub Classroom. So I'm going to go ahead and click this. You're going to be asked to choose your name. Please choose your real name. This links your IU username to your GitHub username for me. If you don't have a GitHub username, you'll have to get one. So you can look through here, find your name. So I can find CW Sexton here. I just saw it. And then it will clone the repository into your personal space, a repository that you can access. It'll be named this long conglomeration after you press this accept assignment button. I'll go ahead and press this. And that is the way that you will turn in assignments to me in this class. So you will create that GitHub assignment. This page will update when it's done. They've actually updated this a little bit. But then you'll have the starter code for the project for each week. I would like it to finish so that I can show you kind of what that looks like. Come on. There we go. So your assignment, I had to manually refresh that, by the way, but your assignment has been created. It'll give me a link to it. Looks like I've already done this one before. So I got a -2. But here you go. This is my project. You can clone it using this URL. You will probably have this HTTPS or maybe the GitHub client or whatever. But you can clone it here. That'll get these files on your computer. Again, we'll talk about Git in a separate video. I don't have time right now. This page, though, includes all of the instructions, right? So as you go through this, there's instructions on how to get started and how to do the assignment and what to do for it. So you should follow this kind of step by step and finish whatever code there is. All of my assignments have a testing suite where you can run some tests. I have different tests. Yes, Writer is great for all of this work. I recommend it. And I'll show you more about that in a little while. That's kind of getting ahead of ourselves, but that'll get us there. All right. Now, let's see here. How do I want to do this? we're gonna go into the actual meat of this for right now, and I will show you myself using Writer a little bit as we go. All right. So what I'm going to do now is I'm going to flip over and we're going to start in what we're calling Chapter 5. One side note about all of these notes, they are titled for an ancient book. We don't have a book, you might have noticed, so chapters are a little bit irrelevant. But there are cross-references through some of these notes, so I've been a little bit nervous to actually update them. So there are a bunch of chapter numbers. They don't mean much. They're just out of order. They just identify things. So just keep that in mind as we look at all of this stuff. All right, so I'm going to grab this on my iPad. Oh, I'm not casting yet. Oops, I forgot. Let's get that started. All right. Open in GoodNotes. Import as new document. Someday there's air server. So here is iPad. A black screen. How do you like that black screen? Does that look good? All right. Here is our notes. All right. So this is our first look at F#. Some of this stuff is kind of real basics, kind of looking at the meat and potatoes of it. But I want to stress real carefully here that F# is probably very different from any programming language you have used before. It is got very different syntax than like a C-like language, so it's got very different syntax than like Java, very different syntax from Python or any of those kinds of things. But I think that you should be able to pick it up as long as you pay attention to some of the things that I mentioned here. You should be okay. But it is subtle, so we'll have to really think about that some, right? So first off, why F#? Well, one of the learning goals here is that we need to learn functional programming. And F# happens to support pure functional programming. F# is a very high-level language. It runs on the .NET CLR, which means that it is a virtual machine language. But it is a functional language. We can use it interactively and we can use it non-interactively. So the homeworks are non-interactive for the most part. I think there's one homework that's interactive still. When we're trying stuff out, when we're in class doing stuff, we can actually type F# commands into a prompt and see the results immediately, which means that we can iterate and try different things, and it's very nice. You won't believe me yet, but the fact that we have few side effects in the way that we're going to use this means that we can reason about a program without needing to run it. So we can read code and deduce what it's going to do, and we'll talk about that quite a lot. F# is object-oriented, but we're not going to necessarily use that feature of it. But we will use this thing called pattern matching. Pattern matching is cool, and it's a thing that's coming to many other languages these days. But in languages like F#, that's where it kind of came from, and it's a powerful thing to use, right? And we are going to use it for a bunch of assignments. In particular, we'll have a programming language that we write in F#, which is kind of neat. All right, so functional languages. What do we got? Well, we had the factorial function before, right? So we can say that we can create a factorial function. So this is factorial of the argument x. This rec right here means recursive. So any function that's going to call itself, which is going to be a very common thing for us, must be called with, or must be defined rather, with this rec keyword. And we can see the meat and potatoes of the function. Now, every function in F# must return a value, right? So we don't need a return statement. Everything we do is actually an expression which means that this if is not an if statement, it's an if expression. So whatever is in the kind of then areas of that if are values. So if x is less than or equal to 0, right, we're going to return 1. Otherwise, we're going to return x times the factorial of x minus 1. Right? That's kind of how F# functions look. All right. So F# itself is an open standard. It's an open language. You could implement an F# interpreter if you so desired and follow their specification. Originally, it was an implementation one-for-one of a language called OCaml. OCaml looks very much like F#. It has some differences as far as features and things like that, but it is a very similar language. So if you get through this and you know F#, you also are pretty close to being able to use OCaml in a reasonable way. It supports functional programming fully, which is why we're here, right? It has a very strong static type system. Now, this type system is the thing that people complain about. So if you've been in, I mean, we haven't been in a programming lab for a while, but if you've been in a programming lab, and you hear people complaining about F# and programming languages, they're probably complaining about how strict this type system is. But I hope that I can convince you that it's actually a benefit and it's pretty freaking cool, right? All right. We could discuss artificial intelligence and its relationship to functional languages at a different time. It is useful for that, but maybe not the kind of artificial intelligence that might come to mind first these days. Okay, you can try F# in the browser. I think this page still works, although the last time I did it, I think it relied on Silverlight, so it may not anymore. There are some other things. I should get rid of this whole slide, to be honest. There are some other things that you can do to try it online, like REPL.it and things like that. That said, there's no reason to try it in a browser for us because we can just go grab .NET Core and we can grab Writer. Oh, I forgot to mention that we do have to get .NET Core first. My bad. So over in our web browser, I'm going to go ahead and, well, I think I actually linked this one somewhere. Where did I? Oh, I guess I linked it in that slide. If you search for .NET Core, you'll get the right page will be the first result. We want to use .NET Core 5.0, that is current. And you do need to install this. I don't recommend installing out of like Visual Studio or like from the IDE. You might install the wrong thing on accident. This will get you the right thing for sure. And if you click it, you'll come to this page and you just need to pick, I would pick the right installer for your platform. So if you're on Windows or Mac OS or Linux, they have instructions here for you to install the SDK. That is what you want though, the SDK 5 installer packages for your platform of choice. I'm guessing for most of you that is this x64 link under Windows. But yes, make sure you get .NET Core. You will need that for sure. All of our stuff does technically work also with .NET Core 3.1. That's what I was using last semester. But we might as well keep current with .NET 5. All right. So if you have .NET Core installed, you can pop up a terminal. On Windows, this is a little bit harder. I actually think this .NET FSI command works on Windows with .NET Core. The FSI command on Windows is like hidden somewhere deep in the program files, directories, and all that stuff. But I'll show you what this looks like. If I can find my terminal on my screen. Here we go. So if I run .NET FSI, it doesn't matter where I do it. Again, your mileage might vary. We get up a little prompt and we can type in .NET F# commands and immediately see the results of them. I say immediate, my computer is doing a lot of work on this stream, so it might be a little slow. So anything that we do in a slide or in class, one of these kinds of .NET FSI windows will work. I'm going to also show you how to do this right inside of Writer, which will give you the added benefit that you can write it in a file and send it to this interpreter, so that you can try things and iterate on them and send different code and all that stuff and not lose your progress. Because as soon as I close this program, to get out of that, I press Control-D. Oh, I'm not running my KeyCast app. There we go. Now I have a KeyCast in the bottom corner. Oh, in the bottom corner. In the bottom corner. There we go. So you can see what keys I'm pushing. .NET FSI, enter. So I can type 4 times 4, enter. Just so you see what all these buttons actually mean. Control-D gets you out, right? So that's .NET FSI. It's one way that you can run cross. Yeah, they are doing something with .NET 5. Technically, it is still .NET Core, and the identifier for it is .NET Core. Like, it is .NET Core. It's just branding that they've done to unify the two competing .NET versions together. So, yeah, if it says .NET 5, you're fine. All right. All right, let's keep going. So how about a simple example? 1 + 2 × 3. This is what things look like. Whenever you're running in the interactive window, the things that you type in an expression. So an expression like 1 + 2 × 3 here. You end that expression with 2 semicolons, not 1. And that signifies to the interpreter, hey, I need to run that line of code. And it will print out whatever that expression returned. Now, what you're seeing there is what the value 1 + 2 × 3 is. It happens to be stored in this temporary variable called IT. And what we see here is that they have assigned the variable IT. It is of type integer, and its value is 7, right? Now, F# infers that type. We didn't tell it that this was an integer, but it knows. That is an important theme that we're going to come to quite often, right? Now, I am going to switch over to Writer real quick and show you me doing that in Writer. So if I hit the IDE here, I already have homework 1 open. You can create a new project if you like. So I just went, you can't see my file menu, but I went to File and New, and I would suggest a console application. You can give it whatever name you like. Just make sure that F# is selected, and make sure that .NET, oh geez, why isn't it in here? .NET Core. Where is .NET Core 5 here? Oh, the SDK is already chosen, so you can ignore this. So as long as F# is written here and SDK says 5, you should be okay, right? So I'll go ahead and do this just so that we have this empty project. I'll come back to our homework project later. Don't worry. We'll do it in this current window so I don't lose it on the stream. All right. So this is a console application, but I don't really care about any of the files that are already here. All I did was set this up so that I had a F# project to start with. What I suggest that you do is you go in here and you say add, and A Scratch file actually works just fine, but I suggest you add some kind of a file. You'll select F# script, not regular F#. And you notice up here it says scratch1.fsx. It looks like it came with a scratch.fsx, so, you know, whatever. And in this file, we can type whatever code we want to type in. So I can type 1 + 2 × 3, semicolon, semicolon. And if I press Alt-Enter, I will get this little pop-up. And you see the first thing in this pop-up, it says send line to .NET or to F# Interactive. And there is a shortcut there. So that little shortcut says Alt/. I've actually changed that because I use the regular shortcut for a different application. But I can just press Enter on that, send that line to the interactive. And this window down here will pop up, which has the interactive, right? And it sent it, you can see right down here, val it = 7. And the first time you do that, there's some like mess in there. So like the second time you do it, you'll just see your line of code and the result. So you can keep sending code down there as we write more. So I might write 2 + 6 × 8 or 9. And I can send that. I may not be able to use writer in class. It's kind of slow. I can send that line over to the interactive, no problem. The other thing I can do is I can send multiple lines. If I select both of these, I can send selection to F# Interactive, and it will interactively execute those lines of code. By doing this, it means that I can see in a history and I can edit what I've sent over there. So if I want to change this somehow, maybe I want to change this to 9 now, I can kind of iteratively do work. Now, the other thing is you can click down here at this little prompt and you can type your own thing. So, 2 × 7 + 4. And that works just the same, right? So you have some options in the way that you interact with F#. I only put 1 semicolon on that, sorry. In general, make sure you put 2. F# is a little bit lenient about some things and very not lenient about others, so you might learn where you can cheat and where you can't as we go. But that's kind of the basics of running anything with F#, right? So we're going to look at some stuff. I'm going to cut it off in half an hour, so we're not going to get through this chapter, so that I can show you what the homework looks like and you can play there. The homework depends on functions, and it depends on tuples and lists. So what we do today might not get us quite what we need. You may be able to infer. If you want to do that, that's, be my guest. But there's plenty of time right now that it's not a big deal if you don't start this weekend. What I do want you to do is get your development environment set up this weekend. So get Writer, get .NET Core, get, make sure you can clone the repository. Those things are things that you should do immediately. But it's not necessary that you complete the homework this weekend. We have another week to do it. That's on purpose. I'm thinking about you. All right, so I'm going to kind of breeze through some of these things because they're not really that interesting. I'll note the things that are important. All right, so for instance, .NET, or F# rather, has number constants. Go figure. But there's an interesting thing about these. Notice if we type in the console 1234 or 123.4, we get a different result. And that's because the constants that you type in, when you type in a number into the .NET, into the F#, what numbers you type in matter. It changes the type, and types aren't really compatible. So if I type in 123, right, we see integer 123. If I type in 123.4, we see float. And those are, in fact, different. All right. You'll see why in just a moment. We have Boolean constants, true and false. It's worth noting these are always lowercase. And the other thing that you want to note everything you can about types. So notice here the type of these is bool, all lowercase. Types are very important in F#. I've got to stop saying .NET on accident. Types are very important in F#. If you get your types confused or you don't understand what a type of a certain value or variable is, that's where you start having problems, right? You need to understand what type everything that you see in your program is, and you should be able to do that mentally. Your IDE will help you. Like it annotates these things, and you can type into the F# interactive window to find out what types certain things are. But it is vitally important that you can infer things for yourself. Okay. So, character and string constants also exist. Go figure. Strings are denoted by quotes. This is where I get to warn you, do not copy and paste out of these slides. You will be a sad person. You might notice that these quote marks are not the same. These single quotes aren't really single quotes. These were written in PowerPoint, and PowerPoint very helpfully changed everything. Which means copy and pasting out of this is fraught with terror. All right, so just know that. Besides that, it's not a good way to learn. You need to type these things in. You need to experience the common pitfalls and common errors that you might come across. That's how you learn. So just take my warning, never copy and paste out of these notes. You'll be a happier person for it. Okay, so strings denoted by double quotes, characters denoted by single quotes. We have a lowercase string type and a lowercase char type. If you want new lines or tabs or things like that, it's just like in Java or C or C++, no problem. There you go, those are strings. Let's talk about more interesting things, like what can you do with this stuff, right? The normal arithmetic exists, right? So all of the normal functions that you might expect, you can negate values, you can add, subtract, multiply, divide, and take a modulus. I don't suspect that any of that is surprising. However, note that all of the values that we see in both of these expressions match, right? So every value in this first expression is an integer number. No value has a period in it and another number to denote the tenths place. Likewise, in this second expression here, all of the values in this expression have a .o, which means that every single one of these values is a float, which means that the result is a float. You'll see why in just a second, but I want you to pay attention to types very carefully. I'm doing my best here to make a really big deal out of this, because the more you pay attention to those types and the earlier you say, ooh, I need to pay attention to those types, the easier this is, right? So we got integers, we got floats. The plus operator also works for strings. So if you want to concatenate strings, you can use the plus operator. Normal operators like less than equal, greater than equal are all defined as well, and they will work for strings and characters and numbers, right? So all of the kind of normal things that you would expect from a language exist. Again, I don't think that this is going to be surprising to most people, but it's there, right? Now, there is one operator that's a little different, and that is the equality and inequality operators. So if you want to check if something is equal to another thing, you use the single equal operator. And the reason for that is that the syntax of F# is such that we don't have assignment the way that you do in other languages. The assignment operator is different. It's still an equal sign, but it works differently, and it's only used in very specific situations, which means that the Boolean equal operator can just be a single equal instead of the double equal that you might be used to in most other languages. Now, likewise, we don't have, usually you would probably expect, is that an exception? Usually you would probably expect not equals to be like that, but it's actually less than and greater than. I'm going to check something real quick here. Yeah, that's not an exception. This is an error in this slide. Not an exception. It's just false. Or, sorry, just true. My bad. All right. So I'll do some of these over here just so you can see that. So true, not equal to false. True, regular equal sign, true. True. If you accidentally press enter in the interactive without putting double semicolons, you can always just put them on the next line. It doesn't hurt anything at all. So like 2 equals 2, true. 2 equals 4, false, etc. None of that is probably all that surprising. If you want to string a bunch of booleans together, you can do that. The ampersand and the pipe operators exist, and we have a not for negation inside of a statement, right? All right, so again, I don't think that's all that interesting. It's just kind of trivia at this point. But we're going to get to more interesting things presently. So first off, one little behavior that we have, this is the behavior in many languages, but it's no exception here. When we say, hey, I've got something or something else, we have short-circuiting in F#, which means that this expression right here doesn't ever get evaluated. F# doesn't even try to run it because it doesn't need to. These Boolean expressions are evaluated left to right, which means the first thing that we come across in this OR list is true, which means I don't need to evaluate the right hand of that OR because true or anything is true, right? So just so you know, we have short-circuiting. It does exist. It'll come up in a couple of weird places. It's not massively important to us, but it'll come up in a couple of weird places later. If you want to use the if expression, you can do so. This is where types are going to start coming in. We see that down here. If is an expression, not a statement, which means that it returns a value, right? So what you see here, we have if, and we have some Boolean expression that we can evaluate. So this, whatever's here, has to return a bool, true or false. We have then, and we have the first value. This is the value that this expression returns when 1 is less than 2. We have the else. This is the value that we return when it's not less than 2. Now, of course, this will only ever return 1 less than 2. Same thing here. We have 1 greater than 2, then 34, else 56, and we return the integer 56 here. Now, this line illustrates to you that, yes, this is an expression, not a statement. So we have this 1 is less than 2, then 34, else 56, which means this value right here must be true because 1 is less than 2. So the expression that's in these parentheses returns 34. After it returns 34, we add 1 to get our 35 out. All right? Now, let me go over here. In general, your if expressions are always going to have an else. So if 1 less than 2, then 34, else 56, we know that this is going to return 56, right? Or sorry, 34. If I were to take that else off, then we have a problem. The problem is that expressions can only have one value type. And if we have a then 34, that means that this if expression must return an integer. Now, in this case, we know it always returns 34 by reading it, but F# does not know that. So if that Boolean value, if 1 were greater than 2, in fact, we can type that in, we still get this error because now we're trying to do what would happen if it weren't 34. Well, what happens if it's not 34? What happens is a thing called unit, and unit is just the lack of a value. But unit and integer are differing types, which means they're not compatible, and we can't do that. All right? Now, we can see this a couple of other ways. So all of these statements fail. Well, except for... Man, there's another error. I actually did look at these slides this morning and missed this. Another error. All of these would fail except for that middle one now that I fixed it. But you can type these in yourself and see this, and I recommend that. So if we say if true, then 1.0 else 2. The problem with this statement is that 1.0 is a float and 2 is an integer. And F# is very helpful with its errors. You need to learn how to read these errors. You need to keep in mind that errors are not saying that you're a bad person. They are here to help you. So take your time. Don't get frustrated. Read your errors. But you notice here it says all branches of an if expression must return values of the same type. The first branch is float, and the second branch is int, and it points to this problem right here. It says, hey, that's not a float right there. That's an int. So it's letting us know exactly what went wrong. You cannot fix this without returning a float some way, right? All right, so if false, then 1.0 else okay. Of course, this has the same problem. It's going to expect that this returns a float because the first branch returns a float, but the second branch is trying to return a string, which means we can't do that. I should have worn my we can't be doing that shirt, actually. All right. So let's think about some of these. I'm not going to run these interactively, but I'll let you do that if you like. What is the value and type for each of these? Now, I want you to think about these values and types. I'm going to give you like 5 seconds for each one as we go through them. And decide what you think it is before I say the answer. Otherwise, you're not getting anything out of this. Usually I would do this in class, you know, but we don't have that luxury. So this first one, we are doing string concatenation. We have 3 strings. You can ignore anywhere in the slides where my strings don't have the right double quotes. But they're all strings. So what's the value that we're going to get out? And what's the type of that value? All right, if you said the value was A, B, C, D, E, F, G, H, and it is a string, then you would be right. So it's a string A, B, C, D, E, F, G, H. I'd like to note one more very important thing. This constant that I wrote down is precise. The fact is that I need these quotes to have an F# string constant. I'm going to ask you on a test what is the value and type for expressions, and if you leave off things like string quotes or point zeros on floats, or if you add a point zero on an integer, you'll get that problem wrong because those are significant to what the type of the value is, right? So this next one, we have if 1 is less than 2, then 3.0 else 4.0. First question, is this an error? Second question, what value does it return if it's not an error? And what is the type of that value? All right, so first question, is this an error? No. You might think at first it's an error because we have integers here and floats over here, but those don't have anything to do with each other. So no, it's not an error because both of the returns of this function are floats, which means that it returns a float. And the value is going to be 3.0. Right? Let's skip down to EFG, because I'm getting bored here. So if 3 is less than 4, then 5. Is this a float, an integer, or an error? Answer, it's an error. Even though we have a return type, we don't have an else, which means that if 3 weren't less than 4, then we would be returning a different type than float. We would be returning the unit type. The next one, does this one work? Yeah, because we added that integer return type. And then the last one, does that one work? No, because we have an integer and a float. The types don't match. It'll blow up. All right? So those are the kind of things you have to look for, and this is why types are so important in F#. They matter dearly. Now, F# doesn't convert types for you. So you might be used to a language where some of these things work. So in F#, we can multiply 1 times 2, and we get the integer 2 out. 1 and 2 are both integers. They produce an integer when multiplied. We can multiply 1 and 2 as floatings points, and we get a float out. That's not a problem. But just like with the if statement, or if expression rather, if we try to multiply a float times an integer, we get an error because the types must match. This is going to be true for all the operators. All the types have to match in order to be an operator that works. Now, the operator itself works for both integers and floats, but the 2 types do have to match. It is not defined for differing types, right? Yes, F# does support explicit typecasting. That's how we fix this, right? So if you want to multiply a float and an integer together, you will need to promote explicitly and decide what type you actually intended to use. This actually doesn't come up that often, but the way you do it is you just put the type constructor, so we have the word float before the integer number, and we're all good. Now, the one thing I will warn you about is that you probably always want to enclose these. I know that these aren't enclosed, but you probably always want to enclose these in parenthesis because the order of operations can get a little screwed up, and you might see an error and think that your code is good, but it's actually not, right? So let me show you that. I think I can exercise that pretty easily by just running that floor 3.6 less than 4.0, but so like if I have, well, let's run floor 3.6 in my terminal here, and we get 3.0. That's great. If I run it with the, well, let's do it without the first. If floor 3.6 is less than 4.0, that one actually worked. Darn. So this is not one of these examples, although I promise you will come across an example and you won't expect it. It's best to go ahead and put parens around whatever you're explicitly converting. All right. And it is worth noting that is conversion, not casting. The difference is maybe minute, but it is a little bit important because we actually get a new value out of that. All right. So what's wrong with any of these? Floor 5. Is there anything wrong with that? Let's go try it out. Floor 5. You suppose it's going to work? It didn't work. Floor is not defined for integers. It is only defined for floating point numbers. All right, the next one in there, seal 5.5. I'm just going to type them in here so I don't have to switch back and forth constantly. Suppose this will work. We got a floating point number. So, yeah, it works fine. 5 plus 4.0, is there anything wrong with that? I hope you said yes, because they don't match, right? If 0, then 1 else 2. Is there anything wrong with this? If you said yes, then you were right, because 0 is not a bool. We do need to have a bool there, right? So if 0 is what, right? We need some kind of information there. Let's try something we didn't actually do. String 97.34. Do you suppose that works? Yeah, it converts it to a string, no problem. I will show you while we're here, there is a thing called print function, and you can print stuff with it. Sorry, you need a format string. So the format string is just like in C or in Java, printf functions, and you can print stuff out. Notice the return type here is unit. It returns a nothing value. This is useful if you need to print something out in like a test case in our homework. Speaking of which, we're only a few minutes away from needing to switch to that. All right. So let's talk about variables real quick, and we'll switch to looking at what we need to do for the homework. If you want to define a variable, there's no problem with that. You say let variable name equal and an expression, right? So if I say let x equal 1 plus 2 times 3, the expression 1 plus 2 times 3 we know is 7, and 7 goes into the variable x. And we can use x after that, right? Now the thing here is that this always defines a new variable. We can't update the value of a variable. That's not a thing, because variables have constant values, right? They are immutable, so we can never update them. But there is a type of variable we can update, but these variables we can't, and we're not going to use the type that we update. You notice this let y here has a bit more complicated expression. No problem, right? So we're going to evaluate this expression first as though we don't have any of this over here. Whatever value it returns is what y's value will be. So if x is 7, which it is, then 1.0, which means 1.0 is the value of y, right? Now there's no problem with assigning and creating variables, but if you try to update a value, if you try to say Fred equal 23, like this line has, you'll get an error back because you cannot update a value, right? So let's go, and actually what's happening here, this isn't an update statement. This is checking to see if Fred is equal to 23, right? So let's go over here. Let's say let Fred equals 23, right? We have Fred. If I type Fred in, Fred's value is 23. If I say let Fred equal true, he has a value, right? It's true. And if I type Fred in here, we can see what the value of Fred is. It's true. It's no longer 23, right? So if I say Fred equal 23, that's seeing if they are the same. And they are not, because they're not even the same type, which means it's an exception. If I say Fred equal true, I get true back. If I say Fred equal false, I get false back, right? That's what Fred does, but we don't ever change the value of Fred. If I say let Fred equal true, this is not assignment. This is creating a whole new variable Fred, throwing the old one in the garbage, literally the garbage collector, and our new value of Fred is the one we have for now on. So we can define new variables with the same name and different types, but it is not assignment. This is not like other languages. All right. So there is a type of variable that you can update, and it's called a mutable. Again, we are not going to use this. You should not use this in any homeworks. I don't want to see it in your code. But not an immutable, so what we've been doing, if we try to use the update operator, which is that arrow there, it will say, hey, this isn't mutable. But if we just put the mutable flag in front of Fred, so we create a mutable copy of Fred, then we can change the value of Fred. So now Fred's value is 24 after being updated. That is assignment, though. That is a side effect, and we are avoiding side effects. So I'm letting you know that this is possible, but don't use it. All right. So if we were to make some of these declarations right here, right? We want to know what the value of expressions are. I'm going to go ahead and do these, right? So let A equals the string 1, 2, 3. Let B equal the string 4, 5, 6. Let C equals A plus B plus the string 7, 8, 9. Right? And let A equals 3 plus 4. All right, so we've run all of those declarations. What's now the value of A? Is it 1, 2, 3? No, it's 7. The value of B? We never really touched B. So yeah, it's 4, 5, 6. My watch is on upside down. I don't know how I managed to do that. C. Is C a valid thing? It uses A, right? And B. So is it 1, 2, 3, 4, 5, 6, 7, 8, 9? Or is it a problem? The answer is it's not a problem because C was calculated when A was still 1, 2, 3. Right? And A equals 6. Is that okay? Well, A is 7 now, so yeah, it's fine. The two types match. Equals is the equality checker, and they're not equal, so it returns false, but it's not a problem. Yeah, it's totally fine. All right. So all of these things are garbage collected. So as we redefine things, as we redefine Fred and A and all that kind of stuff, the .NET CLR in the background will garbage collect those eventually. We don't have much view into that or control of it, but it is a thing. All right, so that's where I'm going to end today. Next time we're going to talk about tuples and lists, which are super duper important and I don't want to rust them. We're going to talk about functions, which are also, obviously I think super duper important and I don't want to rush it. So we're going to save that for next time. That's fine. We're okay. I'm going to switch over and show you how to get and work with the homework. So over in my browser, if I can find it, here we go. I already showed you once checking it out. So down here in assignments, assuming that you've gotten .NET 5, you have a copy of Writer installed, and you have Git installed. I'll show you what's up, right? So you're going to click on the magic link here, and it's going to take you to GitHub where you accept the assignment. If you click it afterwards, it'll say, hey, it's already there, and you can keep going. All right, so here's our beginning F# assignment. You should read through this carefully. And I'll show you what this looks like when it's on our computer. I will say there is one little problem. GitHub doesn't render math. So this is supposed to be the math function here, C. You can Google that. You can read it just without these $, whatever you like. I might update that at some point, but it's too late after you clone it, so that won't go away. If you don't know Git, I recommend checking out some of these introductions. I think these links still work. Yeah, they have a Git handbook here. And I think they have a little course where you can learn how to use GitHub here. They're good tools. But I'll show you what's up. On Windows, I would recommend use PowerShell or the Git Bash. Don't use CMD. It's old and antiquated at this point. I am on a Mac, which means I have regular bash. So that's what I have in my terminal. We'll see that in just a second. What I'm going to do, I'm going to take this URL here. I'm going to copy it. So that's what that button does. Again, you will probably have HTTPS selected there. If you use GitHub Desktop, be my guest, I guess. I don't know a lot about it. I think it works pretty well. it's going to clone to somewhere weird, so you just need to know where it clones to so that you can tell Writer where to go. But I'm going to go ahead and git clone that URL. It'll say I'm cloning it in there. I now have those files on my computer in a directory called C311 Homework 1, beginning F sharp, Chris Sexton 2. This will be the same for you on Windows if you use git bash. Note, I'm in my home directory right now, so you need to change directory into wherever you want this thing to go. But inside this directory, I can list the files. We can see what's here. I can open my file browser, and we can see the physical files here in the file browser. We can look around it a little bit. There's a solution file openable by Writer or Visual Studio. And there are two directories. These are projects. So inside the project, Homework 1 has an fsproj file that represents the project file, and a library file. This is where you're going to put all your code, right? In the tests directory, there is another project and a unit test file. This is where the tests that I've given you live. Now, updating this file won't do anything for you on the turn-in, right? So I'm going to replace this file with my copy. That means that if you change a function so that it doesn't work with those tests, you're going to fail tests, and I'm not going to try to fix your code. All right? I will just give you the grade that comes out. You have the ability to see whether or not your program runs with these test files, so I don't feel real sorry for you if you don't have it working there. If you have a syntax error, your tests are going to fail, and that's important to know. You need to fix those kinds of things before you turn in. So in here, if I've installed .NET, I have the .NET command. If I run .NET test, it's going to look at these directories, find tests to run. The first time it runs, it restores, it installs some dependencies. And it's okay if you see warnings for these projects, that's fine. But all of these red things are the tests that failed. Now, it's running mine twice because I have two different .NET frameworks installed. I think it's going to be okay for you, but I will show you how to fix that if there's an error there. I'm not real sure what's going to happen there yet. I can only test this on the machines I have. Maybe I should try that on my other computer real quick. Not live. I'll test it after. But anyway, you can see here I have a bunch of tests that are failing, right? Now, I'm going to, for free, do one of these for you. That's one way to run the tests. So if I'm doing this without Writer, I can run .NET tests in a terminal window here and see the results. And I could update this library.fs file until it works, right? When I'm done, I would run git add and period to add all the files that are here. And I would run git commit to commit them. And I would run git push origin master to push up to GitHub. Now, again, Git is a separate issue. I'm not trying to give you a Git tutorial because that takes time. I will post a video about it. I have to dig it up first. If you already know Git, that's great. All right, so in Writer, how about Writer? What happens in Writer? So I'm going to go over to my IDE here. And I'm going to go, you can't see this, but I'm going to File and Open Solution or Project. Now, give me a file browser in a second here. You can see here, I already have one of these, but let's open the one I just cloned. So that's this one right here. If I just press open, I don't need to select anything. If I just press open, it'll ask me if I want to open this solution. I can also open this solution. You want to open the solution, the SLN file, not the project files, because the solution loads up the projects for you. So we have two different projects, the source project and the testing project. The tests are how you run these. All right, so if I expand these over here, we can see we have a library FS file and a unit test file. In the library file, this is where you write your code. All right, so this is the homework 1 code. And in the unit test file, you can read this and see what your code is supposed to do. Now, the instructions on the README that you can see in GitHub are also, they include what they're supposed to do, but you can read this file and say, well, if I run GCD with the arguments 19 and 8, they should return 9, right? If I run sort with the list 210, 194, I should get 1, 2, 4, 9, 10 out, right? So this test file can help you if you know how to read it. Now, I'm not expecting necessarily that you know how to read these yet because we haven't talked about it. I just want you to get it so that you can open these files and run them. So the source file contains all of the functions, and they are currently the correct signature and return type. So that means like the function hello returns a unit. It takes a string and it returns a unit. The function returns 1 takes a Boolean value and it returns a number, right? So all of these are already set up to compile, right? Now, if you want to run this stuff inside of Writer, and this is one of the reasons Writer's pretty great, there is at the very bottom here, the default view has unit tests. If you can't find it that way, I think looking through my things here, come on, you can do it. All right. So in the View menu, the very first option is a Tools Windows pop-out, and in there is a Unit Tests. I realize you can't see all of that, but take my word for it. But it should be down here at the bottom by default. If you hit that Unit Test window, it knows that there are tests. I'm going to just run Target Framework 5.0 here. And it knows what they are, right? So if you press this double play button over here, that runs all of the tests. After it builds, it's working. My computer is a lot slower when streaming is actually happening because it's encoding the stream and all that stuff as well, so this takes a second. All right, here we go. So it'll go through and it'll run each of those tests. It knows they're there, it finds them automatically. Visual Studio can do this too, but people generally seem to have problems getting it to actually detect them. Right now, most of these tests are failing. There are 2 tests that are currently passing, because I gave those to you. But you need to fix all the other tests, right? Now, in that test file, next to the functions, there is a play button, right? So if I run, let's do this returns 1, 1, that's the one I want to do. If I press not the format selection button, if I press the play button next to it, that'll only run that one test. Or it should have. It's right over here. Test 1 actually passes right now. A little surprised by that. I thought that failed by default. There's one of these that, and maybe it's in homework 2, that's a little confusing, but returns 1 should return 1, which means that if the unit test doesn't work, that means that when it's false, it should return 1, which means we would want to make sure that Actually, that really shouldn't be passing. It's not passing. Here it is. Right? Return 1, when I give it false, should give us the value 1. If we look at the code is wrong. Because when condition is false, it returns 2. And we can see over here, if we select the returns 1 function here, expected 1 actually got 2. Well, that's no good. So we can fix this. It's not hard. You will have to fix this in your own code. It is part of the assignment. There are options. You could change this 2 to a 1, then it would return 1. You could also just replace the entire function body with the value 1, and it will return 1. So let's rerun this test. Sorry, it's so slow. I could maybe put it into battery saver mode and it might go faster. Gets rid of all the good features, but you know. So we're about to run returns 1. Now we have a success, right? So the game here is to run these unit tests, see what fails, which at first is going to be most of them. And you want to go through the test file piece by piece. So if I look at unit test FS1 here, I want to go through this test file, and anywhere that I have a test that doesn't pass, so right now GC 9 and 18 does not pass, the next thing I would want to do is make this test pass. And the way that you make the test pass is to go find the GCD function and complete it. You shouldn't have to update this test file unless you want to add more tests, right? If you were to change one of these tests so that it passes, you're going to fail the test that I have, right? If you change the function signature so it isn't a function that takes GCD, for instance, isn't a function that takes 2 integers and returns an integer, you're going to fail like the whole assignment because it won't compile when I try to use my tests, right? So pay attention very carefully that you haven't modified this file. If you did, you can run git checkout on the file. In fact, you can do that right inside of here. You can roll it back. That'll check it out. But make sure you don't modify the test file. You want to modify the library file, right? So over here in library, there's one more important thing. I asked complexity on a couple of questions, right? And I've given a word for each complexity class. No ants is the nothing. Yes, that is correct. If you don't modify that test file, then you are safe and your program runs. I'm going to put a syntax error in here. So I'll put like, I don't know, bleh, right? So there's a syntax error right now. If I try to run the test file, it should squawk at me. I hope it doesn't just run the last version that worked. I'll look like an idiot. Regardless, if you have, yeah, there we go. So this isn't going to run our tests because we have a syntax error. If you were to modify the test file in some way, you would have a syntax error pretty quickly. So yeah, try to not modify that file as much as possible. All right, complexity. The default answer is no answer. I put one of these in already for you so you could see what to do. But each of these complexities represents one of these classes of big O complexity, right? So O of 1 is constant, O of n is linear, we have log n for logarithmic, we have n log n squared, and factorial. So I ask you, hey, what is the complexity of the C function? Right now it's no answer. Now the test says, let's go over to the test for C complexity. It says, your answer can't be no answer, right? So as long as it's no answer, your test is failing. Now my test actually asserts that it's correct, right? So whatever you say, as long as you say no answer, your tests are going to pass, but that doesn't mean you answered correctly, right? This is my way of encoding non-code things into a unit test. So you should update this with the complexity class you believe that to be. All right. I did insert complexity for you, so this is what it looks like afterwards. You'll need to do sort and see. All right. Much more of this will make a lot more sense next time, but for this time, it's enough if you can get this checked out and get, you should be able to run the unit tests and see them fail. That is what I would like you to do if you want to do something this weekend. All right. I'm going to wrap it up here. I'm going to go find last semester's Git presentation and post it. So if you are unfamiliar with Git, you need to watch that video as well. It is important. I want you to be able to turn in assignments. There's one thing that I would like to say along with that. If you already know Git, that's great. This advice goes for everybody. Make commits often. Push often. If you commit and push your changes, I can go on GitHub and see your changes and help you with them. So if you come on Discord and say, I don't know why this thing doesn't work, my question is going to be to see your code, and what I will mean is to see your code on GitHub so I can help you. Now, if you're having a problem with the environment and you need help configuring something, that's a different story. But in general, what I want you to do when you want help is to push your code so that I can see it. So save it, add it, commit it, and push it. And we'll look at GitHub together and we'll figure out what's wrong with it. All right? So as much as you can commit, that's better because you can push incremental changes. I cannot give you a grade for no work. So make sure you push often. Right? And then you'll have work in there when I get to grade it. All right? All right. I'll be available on Discord for a while. My next class is at 1, so I'll be around. Have a good day. Have a wonderful weekend if I don't have you in a couple hours here. Bye.